Okay, so in this video we are going to start talking about solving quadratic equations. All right, solving them. Now the first question that we are going to start asking ourselves is that what's the whole reason as to why we solve quadratic equations? Like, what's the whole idea involving them? Well, generally we know that quadratic equations are always written in the form y is equal to ax squared plus bx plus c. And if you notice, the first equation here, 3x squared plus 5x plus 2, is like originally this thing was like y is equal to 3x squared plus 5x plus 2. Now, if we compare the y is equal to 3x squared plus 5x plus 2 with the 3x squared plus 5x plus 2 is equal to 0, basically you're just going to see that the y variable here has been made equal to 0. In other words, what we're just trying to do anytime we're solving quadratic equations is to determine the x-intercepts of that given quadratic equation of yours. Okay, because remember, we always try to say that in the x-axis, y is always equal to 0. That's what we normally say. In the x-axis, y is always equal to 0. So basically here, this is what has happened. The same thing also applies to b. The 3z squared is equal to 7z minus 1. If we look at it, originally, it must have been looking like this. 3z squared minus 7z plus 1. Originally, this is how it was looking like. But when they made y to be equal to 0, that is 0 is equal to 3z squared minus 7z plus 1. If we do a little bit of some rearrangements, we take the negative 7z plus the 1. If we cross them to the other side, you're going to see that this is just going to be 3z squared minus 7z. And that's just going to be, if I don't put minus 7z plus 7z, and this is going to be minus 1. Exactly like what we have been given here. So anytime you are solving quadratic equations, you actually determine your x-intercepts, whereby the y variable is going to be equated to 0, because in the x-axis or any other variable that you have been given, maybe say z, y is most definitely going to be equated to 0. Alright, so this is how it's going to be. Now, when you're solving quadratic equations, there are about 3 methods or 3 ways which we can actually introduce here. There is the first method, which is called the completing square method. There is a completing square method. Okay, there is a completing square method. Apart from completing square method, there is the quadratic formula. Okay, there is also a quadratic formula. Apart from the quadratic formula, well, there is this basic one, the factorization method. The factorization method. Now, the completing square method maybe is going to be explained better when I make some additional mathematics videos, not in this problem. So, one thing that you need to understand is that the format of the equation is normally what is going to determine the method which you are going to use in solving it. Okay? The format in which the equation has been brought in is what is going to determine the method which you are going to use. Either it's going to be the completing square method, the quadratic formula method, or the factorization method. Okay, so the completing square method and the quadratic formula, I want you to understand that these can be applied to all quadratic equations, and your answers can be so direct. You can have your values. But when you're talking about the factorization method, one thing that you need to understand is that not all quadratic equations are easily factorizable. Hence, when you're applying the factorization method, there is some extra caution which you need to take, and I'm about to show you that. So without wasting much time, let us see how we can proceed in answering these things. So at least I had already solved it, so I can be running you through the same things. And in a case maybe we want to copy these things, you can just pause the video, copy them, and then you can be running through with me. Okay, so if we look at it very carefully, these equations, as we notice, are not factorizable. And specifically here, I'm talking about b. The 3z squared is equal to 7z minus 1. And you will see I will explain why it is not exactly factorizable. So the equations are not factorizable, hence the quadratic formula in this problem may be used. Okay, so the other alternative is the completing square method, like I had shown you in listing those methods which we normally use when solving quadratic equations. So the other alternative is the completing square method, which I'll come and show you guys in some other tutorial videos and everything. So let's start with this problem. 3x squared plus 5x plus 2 is equal to 0. If we compare this with our original equation, y is equal to 3x squared plus 5x plus 2 in this problem, and we get 3x squared plus 5x plus 2, but remember this is 0. And just generally speaking, y is always ax squared. The general form of quadratic equations, bx plus c. If we follow it up, you're going to see that your a value is going to be equal to 3. Your b value is just going to be equal to 5. And your c value is just going to be equal to 2. So your a is equal to 3, your b is equal to 5, and your c value is just going to be equal to 2. So this is the whole reason why I just written this, to say let a is equal to 3, b is equal to 5, and c is equal to 2. And I'll consider this one as my method 1. So this is our method 1. So if we get x is equal to negative b plus or minus square root of b squared minus 4ac over 2a, one of the common mistakes which people make is that they normally fixate the 2a only on this side. That is one of the mistakes that they make when writing this. They're just like negative b plus or minus, and then they're just going to say b squared minus 4ac, and then this is going to be over 2a. That's how many people write, and that is exactly wrong. It's not correct. It's not exactly precise. The root, or better let me say, the division extends all the way to negative b. So instead of just saying negative b plus or minus, and then square root of b squared minus 4ac, and the 2a is only under the square root of b squared minus 4ac, then that's going to be wrong. By the way, your b squared minus 4ac is what is referred to as your discriminant. Okay, your b squared minus 4ac is what is referred to as your discriminant. So put that in mind. D, which is your discriminant, is always equal to b squared minus 4ac. So everything should be over 2a, not just the b squared minus 4ac, everything. So you're going to see that on b, we're simply substituting 5 plus or minus square root the 5 squared minus 4, which is part of the formula, a, which is positive 3, your c, which is positive 2, is what we're just putting right there. If we work out this problem and please do punch these things properly on the calculator. Okay, you can just punch the whole of these things on your calculator directly. The answer is going to come out. So if you punch, this is 5 squared, which is just 25, minus 4 times 3, that's 12. 12 times 2, that's 24. So it's 25 minus 24, which is just going to give you a positive 1. And that's the one that you see right there. So negative 5 plus minus square root of 1. Now, we all know that the square root of 1 is just 1. Okay? And this is just going to proceed to be negative 5 plus or minus 1 over 6 here. And having seen that there are two signs here, the positive and the negative, what we normally do is that we split this thing up. We first express it in terms of a sum, and then we express it in terms of the difference. Sum means addition, difference means subtraction. So if we work this out, negative 5 plus 1, the answer is just going to be negative 2 over 3, which on your calculator I believe is going to be negative 0.666 infinity, just going like that. And negative 5 minus 1, that's definitely going to be negative 6. Divided by 6, this is the value, the negative 1 that you are actually seeing there. Okay, so this one can be worked out in this way. Now, there is something interesting though about this one. That's why I told you to say that these equations are not factorizable, but specifically I was referring to B. But I want you to see that this quadratic equation, the 3x squared plus the 5x plus 2, is also factorizable. So in this problem, let us also try to use the factorization method. So in our method 2, this is my guideline. The factorization method may be applied. Now, in order for the factorization method to be applied, your product, sum, and factors needs to be determined. They need to be known. How can we determine our product? Well, we always multiply our first number, the coefficient of x squared, with that constant, which is just like basically 2. So this is going to be 3 times 2, and that's going to be 6. When you're determining your sum, we always pick that middle number, which in this case is just going to be 5. And that's the whole reason why you're just seeing me write 5 here. You should never include the x variable when you are making your product, sum, and factors. You shouldn't try to do that. So once you do that, once you determine your factors, your 2 and your 3, but again, how do we determine them? Well, your factors are these two numbers. How is it that when you add them, when you sum them, they need to give you 5? But when you multiply them, as in product means multiplication. When you multiply them, they need to give you 6. So our factors are just basically 2 and 3, because 2 and 3, if you multiply them, they're going to give you 6. If you sum them, they're going to give you 5. So again, your products here, this is where we also draw our factors from. So let us look at this. Our product is 6. Which two numbers, how is it that when we multiply them, they're going to give us 6? Well, 1 and 6 can work. Apart from that, negative 1 times negative 6 can also work. You still have your positive 6. Apart from that, your 2, when is multiplied by your 3, this is again going to be 6. And also, negative 2, if multiplied with negative 3, you're still going to have your positive 6. So there are about 4 possible outcomes which can result in you having that 6. 4 possible outcomes. But if we look at it very carefully, you're going to see that if we sum them, the question is that are they going to give us the 5 value that we had determined here? That's the question. Now watch this. If I sum 1 and 6, if I add them, the answer is 7. If I sum the -1 and the -6, that is -1 plus -6, this is just going to be -7. If I sum -2 and the -3, well, this is just going to be -6. Remember, when you're actually solving these things, especially having seen that they are having the same sign, we normally just like add them but maintain the sign. So -6, 7, and -7, these are very, very much, let me just say, not the same with the sum value that we have here. They are not 5. So we normally deny these. They are not going to be our factors. That is the -2 and the -3, the 1 and the 6, the -1 and the -6. These are not going to be our factors for this problem. But if we multiply 2 times 3, the answer is going to give you a direct 6, right? And then if we add them again, you're going to see that it's just going to give you a positive 5, which means that 2 and 3 are going to be our factors for this problem. This is the whole reason now why you're going to see us just get these things now as our factors 2 and 3. So here's the thing. Once you determine your factors, we just get them and then we put them back in that original equation. Okay? So I know you had 3x squared plus 5x plus 2 initially. So when you're getting your factors, we always place them on the sum. Okay? Let me be showing that. We always get our factors. And then our factors are put on the sum here. Okay? They are put on the sum there. This is the whole reason why it's now going to be 3x plus 2x plus 2. Why? Because we're getting these factors and then we're directly putting them on the sum variable. Well, let me just say the sum expression here, which is like your 5x. So once you do that, we now factorize them by grouping. So when you're factorizing by grouping, what we normally do here is that we just couple them up together. This is the whole reason why they're being coupled together as 3x squared plus 3x. The sign that is outside here is a positive, so plus 2x plus 2, and this is just going to be equal to 0. So after you factorize them by grouping, you're now going to work on these same things. So what is common here is the 3x. Inside here we're going to have x plus 1. Plus what is common here is the 2. So this is why you see a 2 outside here. And definitely what you're going to have is x plus 1. Well, here's the thing. Factorization and expansion are more like two opposite processes. Okay? Think of factorization, or better, let me say, think of expansion as a means of going forward, trying to increase things. Okay? And then think of factorization as going the other way. They are very, very much opposite from each other. But even though they are opposite, they tend to work together. So what I basically mean is this. If I factor out the 3x here, if I expand, that is, if I multiply my 3x with everything that is inside here, it should give me this original expression. That is, 3x times x, it's going to give me 3x squared. 3x times 1, I mean, that's just going to be 3x, right? Apart from that, notice how is it that even if I factor out the 2 here, 2 times x, I mean, the answer is just going to be the 2x there. 2 times positive 1, then it's going to be positive 2. Okay, positive 2. That is if we expand. So have you seen? This was factorization happening. Expansion, it's more like you're going back to where you're coming from. So again, what is inside here should be equal to what is inside there. The instant this and this are not the same, then there is something wrong upstairs here. So be sure that anytime you're working this thing out, your factors are properly determined, well determined. So again, you're going to see that the x plus 1 is common here. The 3x is having the x plus 1. The 2 is also having the x plus 1. So we can actually factor out the x plus 1 here as well. If we factor out the x plus 1, of course I never showed it here, and I want to show it to you how it's going to be. Well, we're having 3x. Okay, we're having 3x here. Okay, and then 3x, x plus 1, and then we're also having plus 2, x plus 1. If the x plus 1 is common on both of these, if we factor it out, this is just going to be x plus 1. And then what you're just simply going to remain with is 3x plus 2. So that was an extra step that was supposed to be made here, and you need to know it. So what's the fastest way in which we can get to this? Just pair this thing up. That is the 3x with the positive 2. Just pair them up, just write them up, and then your x plus 1, having seen that it's one and the same thing, well, just write it as one thing, and that will be it. Of course, that's an easy way in which we can make this expression that is down here. So once you do that, you now need to equate these expressions individually to 0. Imagine they're equal to 0. So your x plus 1 is going to be equated individually to 0, just like I did. X plus 1 is equal to 0. And your 3x plus 2 as well should be equated individually to 0. Again, that's just what I did. And then once that is done, I mean, this can be properly worked out. Your 2 is going to go this way, so that's just going to be like 0 minus 2. And this is the whole reason why you're having your negative 2 here. Your 3 is that side, and, well, we divide both sides by 3 so that we can find our x variable. And that's it. X will be negative 2 over 3. This is way more simpler than this guy. So if this is x plus 1 is equal to 0, well, 1 can just be taken that side. And this is now going to be like 0 minus 1, which I deliberately just showed you guys so that in case maybe you're a beginner and maybe you have problems with signs, at least you can take note of what is happening here. So 0 minus 1, well, I mean, this is just going to be negative 1. It's basically just like hiding the 0, because mathematically speaking, at times 0 can be considered to be nothing. So that's the whole reason why you're now having your negative 1 there. And that's it for this problem. This is how you can move from, let me just say, this is how you can solve this question, the 3x squared plus 5x plus 2 is equal to 0, just like that. I hope this helps.